Let us see how we can go about now the first example in motion under gravity. So here we have a stone is projected vertically upwards from the ground level at a speed of 24.5 meters per second. Find how long after projection the stone is at the height of this above the ground. Take the, here the value they are giving you to use is what you use, don't or assume. The taking us take the gravitational force as 9.8. Now, if I assume this is the ground, now I'm seeing that the stone from the ground is now going upwards. Meaning, what should come into my mind? I first summarize the equation. They are telling me that at the speed of, so it's moving at the speed, meaning that I have my initial velocity as 24.5 meters per second. Now I have my gravity as 9.8 meters per second squared, because this is the acceleration that is pushed up. Now they are asking me the time when the height is what? When this stone is at h equaling to 19.6 meters. So when I'm throwing it and put it this, so this is the stone. So they want it at this height. They are asking the time when it's at 19.6 meters. They are asking the time for this. So this is when the stone, this is our stone we are throwing. So they are asking for what time is it there. Because it's going up, you start that this is going up like this. So meaning it's going to oppose gravity. So meaning the formula I'm going to use is Rs equaling to ut minus half. Now the acceleration that is pushing it is going to be now the gravitational force. That's why we have d squared. We said whenever it's going up, our A is going to always be negative b whenever it's going upwards. Okay, so what do we have? We have the distance, the height, which is the same as the distance. It's 19.6 equaling our initial velocity, which is 24.5. Then the time is what we are looking for, minus half. Our gravitational force is 9.8, then t squared. So now, how do we go about this? Okay, you can simplify this as 19.6 equaling 24.5 t. Then minus half of this, you get what? We get 4.9 t squared. So after that, you start the mechanism, divide through by negative 4.9. And divide here by negative 4.9, so we shall be having 19.5. So the 0.6 divided by negative 4. Divided by. So here I'm getting, when this divides this, I'm getting negative 4 equaling 2. When I divide it here, I'm getting 5, and this one's going to be now negative 5 t, then plus t squared. So if I call that one, I have t squared minus 5t plus 4 equaling to 0. So how can we express these two numbers? I'm going to get positive 4 when we add. So this is t squared minus t minus 4t plus 4 equaling 0. So how can we factorize that? So this would be t minus 1 to t minus 4 equaling 0. So our t can be a 1, or our t can be a positive 4. Now, when it is 1, we check. When it is 1, when we put in this one, can you get the distance as 19.6? You try when you put in 1 here. We get this distance, and then try. What about when t is 4? Of course, after 1 second, using this how it's covering this distance. So you can test. So then you test for the t. Test for these t's, then you can see which one is going to work for you. So either this into this. Now, after this, now we are going to see how do we now, from this we are going to see now another example. When the body is somewhere, then it's falling downwards. Or when it's somewhere, then it goes up and falls down in the next lesson, probably. So that's it for now. These are seconds, please. Seconds. So you're going to see more in the next lesson. See you there. Okay, so I've added another question here so that we see how we handle this also. So a body is projected upwards using a velocity of this. How long will it take to reach a point of 200 meters below the point of projection? So now this means that the body is a bit up. So to sketch that, you see I put something here so that now this one is now the point where I'm projecting this body. So I'm projecting it upwards to there, then it's going to come downwards. So at this point here, they are asking how long will it take to reach the point of 200 meters below the point of projection. So if this was the point of projection, so meaning that now this one below it, so this one is the 280 meters. But because it's below the point of projection, now this one is going to be negative. Because it's below the point of projection, this one I think you can see. So because it's below, so at here, S is 0. At this point here, S is 0. The distance covered is 0. So below it, so it's that from here, our S is going to be negative 280 meters because it's below the point of projection and since it's going downwards. Okay, so now from here, I know that our S is equal to T plus, now it's going downwards. So it's going to be then plus a half T squared. So from there, you get your calculator. Okay, so now is that our body from here it was projected upwards. So it's going to be it's going to affect this one as a negative. So from there, you can see that our is given, then our initial velocity was 21 meters per second, and then our g was given as 9.8 from the question there. Now, so you can prove why this is negative, because it's below the initial point. Whenever it gets to that initial point, it becomes a negative. So this is our body like that. So now this one is going to be 280 equaling to u. Our u is 21 times t we are looking for, then minus a half 9.8 t squared. This would be negative 280 equaling to 21t minus, this is going to be 4.9 t squared. Divide through by 4.9. So here will be how many? Negative 280 divided by negative 9. Sorry. Okay, so there I think from here you can divide it through by that negative, and then you can easily get the answer there. So I think people can improve. Now here we are going to get to a negative and then a positive. Of course our time can't be a negative, then we are going to reduce it as a positive one. So for that's it. I think we can complete from there. Okay, let me just complete. Maybe you see that this one is negative. Let us take it this side. We can get 4.9 t squared. Then this comes this side. It's going to be, when I take this one is going to become 21t. Then this one is already negative 280 equaling 0. So what do we do? What is common here is that we can just multiply through by 10 so that we make this a full point. So we have 4t squared minus 210t, then minus 200. I mean 800 equaling 0. What can we divide through by? So I can divide here by 7, because 7 is common out. This would be 7 t squared minus 7 here, shall get 30t. Then 7 here, shall get 400. 400 equal 0. I think people can complete, or you can't complete still. Anyway, two numbers I multiply, I get that. And then when I multiply, I get 280. What are those numbers? Okay, so here I think we can get negative 7. Is it? Is it? Okay, so here I think you see when you solve this, you can get your t as t minus 10 into now 70 plus 40, is it 42? Plus 40 equal to 0. So now our t here is going to be 10, or our t here is going to be negative 40 over 70. And now we see, and now the therefore our time is going to be 10 seconds. Why? Time cannot be negative. So that's how we handle this and this. Now, next examples. In the next example, we are going to see more about these ones here and then some proofs. So, see you there.